So hello, we will start now. I'm a senior engine programmer in Flying White Code company. This is my second speech in Poznań. I've had a speech last year about Shadow Warrior and its engine features. Now we're going to talk about our new game, second version of Shadow Warrior, and about its engine. Here you can see an overview of the presentation. At the beginning I will show a brief introduction. Then we will talk about the engine evolution at general level, and the main part of the presentation is about Foliage System in details. Here you can see a chart with some parameters of productions compared. You can see that Shadow Warrior 2 is planned for over 2 years, while previous game was done in 18 months. We have bigger team, about 50 people now, and especially a lot more engine programmers. The game finally have multiplayer. It's our first game on Roadhog Engine that will have multiplayer. Entire renderer was changed from pre-pass to deferred PBR renderer. And also there are some platform differences. The game will no longer support 32-bit Windows. It will go only on 64-bit Windows, supporting DirectX 11, and of course on next generation consoles. Now we're going to talk about engine evolution. You can see 4 steps of the evolution. Every one of them is linked to one release of the game. First version of the engine was made for a hard reset game. The game was using DirectX 9. It was 32-bit process. We had the pre-pass renderer. We have 2 big threads in game and few worker threads for stuff like sound, havoc, loading, etc. 2 years after the release of Hard Reset, Shadow Warrior was released. The game was still DirectX 9, but a lot of new engine features were added to create the game. For example, Foliage System, cutscenes, animation system was extended. We have skin decals, and for this skin decals, a job system was introduced, but it was not heavily used in the game. 1 year after the release of Shadow Warrior, this game was ported to DirectX 11 to new consoles, PS4 and Xbox One. And now we had extensive use of job system. It was heavily optimized. And now we are at step 4. Shadow Warrior is planned to be released in 2016, the Shadow Warrior 2 game. It has a new renderer, physically based renderer. It has multiplayer. We have also procedural character destruction, and a big change in level pipeline occurred. Now we will talk about this level pipeline. All games before Shadow Warrior 2 was created in that way that level was constructed mainly outside the game editor. It was constructed in 3D authoring tools like 3ds Max. In Hard Reset, there was this big mesh created outside the engine, and there were some smaller meshes that artists were able to place inside the game editor, mainly destructible objects. In first version of Shadow Warrior, this big mesh was split into several meshes, so they was loaded or unloaded. we have had still these smaller meshes, and new part of the environment was the foliage system. Game editor was simple and mainly used by the designers to place gameplay objects like triggers, paths for scripted moves, and so on. In Shadow Warrior 2, on the other hand, we have randomized maps. There are 4 levels of this randomization. Large-scale randomization. The level is constructed of many blocks. They can be rotated. They are connected together with special pre-made parts called connectors, so they can fit nicely one to another. And there are also some background blocks without gameplay or physics. The second level of randomization is a small-scale randomization. We are able to choose some parts of a block for current level generation. This is done in that way that some parts are put on the layers. Then these layers are selected by the tags in the level generation process, and with this we get this randomization of the level. Also, we have random interiors. When artists create houses, they can create many interior of the house, and this interior can be selected during level start. And there is fourth option, the random web. So now the level construction is done in the game editor, and to make it possible, a lot of new engine features were added, including the terrain system, the geometry brush. Geometry brush is a tool for creating simple meshes. It's especially used at first months of the development. The designers can create prototypes of levels with this tool. We have wire modifier. With this tool, we are able to create some skeleton for static meshes and deform these meshes, and then they are baked again to the static meshes, so they are not skinned in the game. And also we have scaling support. It allows us to raise some assets like rocks and so on. Now we're going to talk about character destruction. Hard reset had character destruction. We had a ragdoll breaking mechanism. We were able to split ragdoll between the bones. We were also able to swap chunks of the character, so we could change non-destroyed chunks to destroyed ones. Also, some parts of characters were falling on the ground, and they were changed to static meshes. And on top of that, there was a technique of swapping textures, again, non-destroyed, destroyed one. This technique was fast. It had a low memory cost, but it was limited to meshes like robots. In hard reset, most of enemies were robots, but with these techniques, we were unable to split human-like characters, because in these human-like characters, near the joint you have vertices skinned to more than one bone, and these bones could be on the upper side of the split. The other disadvantage of the system was that the destruction took place only in these predefined places. For Shadow Warrior 1, this mechanism was advanced. Now we were able to destroy human-like characters because after destruction a separate skinned mesh was found, and on this mesh these bones that were not visible was not moving. Characters was made of many parts, including standard skin, gore meshes below it, or even the skeleton below these gore meshes. We still use these static meshes, and we used skin decals. They were new to this game. Of course, skin decals were used to spawn bullet holes or wounds or stuff like that. In this game we had excellent quality of the meshes, but at the cost of a lot of work for the artists. Speed time cost was low, but again we had destruction only in predefined places. Now we are making Shadow Warrior 2, and for that game we created procedural character splitted. It's done at runtime. Both the mesh and the ragdoll is split in any place we want. We have also the whole system. The system works in that way that we have pixel shader that discards some pixels inside the whole shape, and to make sure that we cannot see inside of the mesh, there is a special wound chunk spawned inside this area. Of course, because of this, holes are only in pre-made places. Static meshes are still used, also skin decals are still used, but also we have material modifiers. They allow us to modify a large area of the character. So we finally have unique cuts. There is less work for the artists now, but we need more memory for a new version of the meshes, and also some splitting time. And there are some constraints for the artists because not all meshes can be split. They must be made in a special way. Game is still under development. This system is also still under development, so maybe it will be covered in future presentations. Now we will go to the Foliage System. This is the second version of the system for Shadow Warrior 1. The Foliage System was created, and as you remember, the levels were created outside the game editor, so the system was invented in that way so artists can create foliage outside the game editor. I invented the technique called spawn meshes. These were meshes with relative foliage density stored as a vertex color. This technology is described in my last year presentation. You can find it on my Twitter account. Now we are making new game. We wanted denser foliage. I advised the artist to create bigger meshes, and also I reduced the instance size to lower gather time on the CPU. But the levels are created in game editor now, and we have this random level generation. So I reinvented the entire Foliage system to make foliage for new game. The system consists of 5 main classes. 4 of them are new. One was already present in the previous version of the system. And now we'll talk about one of them, the Foliage layer. This class is main idea of the system. Foliage layer contains instance transformation in local space. We have one layer for every object that has foliage painted on it. And because we have transformation in local space, objects can be moved, can be scaled, and so on in the editor, and the foliage will be recalculated. We use this information from the layers on the level start to generate the grid, which is then used to gather data and pass it to the renderer. Here you can see how foliage layers are linked to game objects. It's shown placeables, but foliage is usually on placeables or derived. Game objects can be in a hierarchy, while foliage layers are on the same level of hierarchy. They are linked to the game objects by the name. They use similar name. Some details about the layers. Foliage layer stores positions in full floating point vectors and normals at these coordinates in half floating point vectors, together with other parameters like coloring values and so on. Foliage from some areas can be blocked using entity called foliage blocker. For example, we don't want foliage under some asset, and this asset is only placed in one randomization of the level, so we can put this foliage blocker into this asset, and when it will be chosen for the generation, there will be no foliage under this asset. Typically we have 1 to 200 layers per level block. As you remember, there are several blocks per level. I believe this will be the final numbers for the game. And the entire system is again designed in this way so artists can change brush parameters without need to repaint the foliage. Another important concept of the system is a foliage palette. Palette consists of many sets. Set is a kind of a brush. One set can contain many elements. Every element can specify one or many geometries together with their parameters. Now you can see a screenshot from the Foliage editor. On the left you can select a set. One set is selected. On the top there are elements of this set. Again, one element is selected, and there are properties of this element. Some of them are new, some of them were already present in the previous system. Some are changed by similar to the previous ones. And I will talk about some of them later on. You can see a painting tool. It's part of the level editor. We are able to select the set, to set the brush radius, set its density. Density is counted individually per each set. So we can paint with, for example, 2 instances of leaves per square meter in one area, and again with 2 instances per square meter with grass in that area, and we will have 4 instances per square meter in this area. We can also select some critical angle. It's used to deny painting on some surfaces. For example, we don't want to paint on the vertical areas of the stairs, so we can set this angle and proper vector, and foliage in these places will be discarded. We can also choose if we want to paint on translucent or to ignore them. It's useful when painting on or under the water. Here you can see another setting of this editor, the coloring option. We can use constant or background color to color instances. This color can be randomized for every instance in HSL space. Never try it in RGB space because you will get ugly results. Also, this coloring can be blended out when moving up with object space Z coordinate. It's set in the material editor. When the foliage is generated at the level start, it's residing in the grid. In the Shadow Warrior, we have many grids, one grid for every batch. But now we have a software visibility test for the foliage, and also we use more batches. So this system was changed in this way, so we have one grid to store every batch. And in this way we can get rid of this redundant visibility test. Here you can see a compared structure of the instance from the previous game and the current one. The size was cut down by half. You can see that in the previous version we stored entire transformation. Now we just store parts of the transformation. Rotation is stored as half floating point Euler angles. We have X and Y coordinates of the position stored as 1 byte each. Z coordinate is stored as silent integer, and we have position resolution about 1.6 centimeters with minimal and maximal Z about 500 meters above or below 0. The size is generated at runtime. It's no longer stored. We have this one spare component in the Euler vector, the W component, and it's used for storing LOD and batch indices. Now we'll talk about imposters. One of our engine programmers created imposters for the static meshes, so they could be used as last LOD for static meshes. In these imposters we have diffuse and normal maps. We can generate many angles of the object, and this system was adopted for the foliage system. I added a yaw-only rotation. I also added sharpening option, which is especially needed for the foliage, because when we render these objects to texture, we lose depth information, and with it some of the high frequency detail of the image. So sharpening can fix it to some degree. And also I added background color to get rid of filtering artifacts at the edges of the branches. Here you can see imposter parameters in the palette editor. Imposters are enabled by default. Artists can disable them for sets that don't look good with the imposters. They can select how many angles of the object will be baked to this imposter textures. They can select also sizes of the textures, the ratio of the range at which imposter will kicks in. Also this background color and enable sharpening. Here you can see how LOD works for the foliage. For high and ultra setting, there are three levels of LOD. The main level consists of 100% of geometries. Then we have imposters, and after that only 20% of these imposters. For the low setting, we have only two steps, 20% of the meshes or 20% of the imposters. Of course, between these stages, dissolving occurs. On these two slides, you can see a screenshot taken from the editor. It's part of E3 level. In the rectangular area, you can see how foliage looks when imposter or the mesh is rendered. Here you can see imposter system disabled and now imposter is enabled. We can see the difference, especially because I instantly switch between these two images, but still we have nice view of the foliage. As I said before, terrain system was added to our engine, and we usually place foliage on the terrain. We don't want to repaint foliage every now and then when we change shape of the terrain. So the foliage position and normals are recalculated. The difference in the recalculation process compared to the normal painting is that we use a position and normals calculated from the height map, while when we paint originally, we got this data from the GBAP. At the end of our system, these grids are traversed on separate jobs. From these jobs, we receive many arrays of vertices, which are then copied to a single dynamic vertex buffer for rendering of the meshes, or they are passed to the imposter system. Rendering is done in two passes. We have main gbuffer pass, and also we have directional shadow map pass. Shadows are new in this game, shadows for foliage, of course. In the previous game, we hadn't shadows for the foliage. In the editor, there is also third pass used when picking is enabled. Here you can see a to-do list. Coloring on the imposters was already done in the recent week. I don't use masks when coloring imposters, while when we render full meshes, coloring is masked out by some texture. Probably dedicated instancing vertex format will be added because now this instancing vertex format is reused from the particle system, and maybe a reaction to the passing characters will be added. We already have wind for foliage and trees, and maybe it will be expanded to react to passing enemies. Now I will show some movies from the editor. Here you can see painting terrain with the grass. Now we use coloring using randomized background color. This background color is calculated at every frame from this area inside the brush. Now again we are painting some leaves. Now with the background color without the randomization. And again randomization is enabled. You can see color results are nice and natural. Here you can see how foliage reacts to changes in the terrain. So creating some ramp. It's cool tool in our terrain editor. I discovered it when creating the foliage system. And now we are cutting the hole in the terrain. The foliage in these areas is disappearing, and of course when we restore this terrain, foliage is lost. Here you can see painting a big rock with some foliage. I will show how update all the foliage works. First we will scale the object. Local positions are kept, so now the density is lower. Rotating and moving the object. Probably some of you that use engines like Unreal Engine are familiar to this functionality. Now we again paint the foliage with a highly visible green color. You can see the blending between the last color and selected. And once again, randomization. Somewhat realistic. I would like to thank our artists, especially Łukasz Dunowski, our lead artist, Zbigniew Siatek-Siatecki and Marcin Sapieński, our environment artists, and to Przemek Witkowski, our 3D engine programmer who created imposter system, and also to our producer Artur Maksara for making information about my speech visible to a wider audience. I would like to thank also to our entire team and to the staff of the conference. Thank you for your attention. Are there any questions regarding the presentation? You can ask questions in Polish if you want. Okay. So if there will be any questions to me, you can find me on the calls of the conference. Thank you.